Hey everyone, and welcome to the data pre-processing video in Python. So, are you looking to unlock the power of machine learning but feeling overwhelmed by raw and messy data? This video will help you with the essential skills to transform your data from chaotic to champion. So, why is this data pre-processing crucial? So think of it like building a house. So before laying the foundation, you would not use uneven bricks or leave gaping holes, right? So similarly, clean and structured data is the bedrock of successful machine learning models. So missing values, inconsistencies, and incompatible formats. So these type of things can all hinder a model's ability to learn and make accurate predictions. So, what's on the menu today? So, we'll be diving into a practical step by step example using Python, and this example will cover important essential libraries and taking care of missing data and encoding the categorical data, encoding the dependent variable, splitting the data set strategically, and also we finally do the feature scaling also. So by the end of this video, you will be confidently handling various data pre-processing tasks using Python and also equipped to prepare your own dataset for machine learning projects, and you will be ready to build robust and accurate models in future. So join with me and get ready to conquer the world of data pre-processing. Don't forget to like, subscribe and hit the notification bell to stay updated on more exciting machine learning content. Okay, I will be using these code examples to show you how data pre-processing works in Python. In this video, I will explain each section in detail so you can also familiar with data pre-processing techniques in Python. So without taking too much time, let's dive into the first section, importing libraries. So, in data pre-processing in Python starts with familiarizing yourself with the right tools. So, these tools come in forms of libraries. So, they are like pre-built collection of functions designed to simplify specific tasks. So, in this crucial first step, we will explore three fundamental libraries for data pre-processing. They are pandas, numpy, and matplotlib. First one is pandas library. So this pandas library actually expert at handling tabular data similar to spreadsheets. So it allows you to load, clean, analyze and manipulate data frames. So making it an invaluable tool for data wrangling and analysis. The second one is NumPy. So this NumPy library provides powerful tools for working with numerical data. So including arrays, matrices and linear algebra operations. So it's fundamental for various scientific computing tasks. And the next one is matplotlib. So this library actually offers functionality for creating various visualizations like plots, charts and histograms. So this will help you to explore and understand your data through visual representations. Importing these libraries in Python is simple as this. From this line of code, import numpy as np. It imports the numpy library in Python and assign alias np to it. This import keyword is used to import modules or libraries in Python. NumPy specifies the name of the library that we want to import. As said previously, NumPy is a fundamental library for scientific computing in Python, and it provides powerful functionalities for working with numerical data, arrays, and linear algebra. This NP part assigns an alias NP to the imported library. So this allows us to use NP instead of entire NumPy every time we want to use its function in future code. From this second line, import matplotlib.pyplot as PLT. This imports the plotting functionality from the matplotlib library in Python. Matplotlib.pyplot. specifies the full name of the module that we want to import. Matplotlib is the main library for creating visualizations in Python, and this PyPlot provides a convenient interface for creating plots. So as same as previous, we have PLT alias for this import, and this alias allows us to use PLT instead of the entire matplotlib.pyplot every time that we want to use its functions. From this last line of code, import pandas as PD. So this line imports the pandas library in Python and assign the alias PD to it. This pandas specifies the name of the library that we want to import. So as said previously, pandas is a powerful library specifically designed for working with tabular data, so often referred to as data frames in Python. So this PD alias, this can be used instead of the entire pandas name every time that we want to use function inside pandas. So this alias will make your code more concise and readable. So now let's run this section. Okay, it ran successfully. So remember, these are just the building blocks. As we progress through our data pre-processing journey, we will leverage these libraries and explore various techniques to transform raw data into clean and well-structured format. Now we have imported the essential libraries. It's time to bring the data into play. So in this step, we will leverage the power of pandas to import our dataset from its raw format, typically a CSV file. First of all, I will show you our simple dataset that we are using for this example. Here is the data set. This contains purchase details of customers for a specific product. So first three columns have the customer's country, age, and salary. So this last column has the purchase status of the product. So this CSV file acts as a treasure chest containing rows of data points and columns representing different features. So pandas help us to unlock this chest and organize the data in a structured format called a data frame. Here's how we import dataset using pandas. This PD dot read underscore CSV part. So this part instructs pandas to read the data from the file name data.csv, the file I showed you previously, and this dataset variable stores the imported data as a pandas data frame. So think of it as a giant table where each row represents a data point and each column represents a specific feature. So once you import it, you can explore your data. So let's run this line and see the output. So this will display the content of your data frame and giving you a glimpse of the data structure and values. So next we have to prepare our data for further processing by isolating these features uh, you want to use for prediction and the corresponding dependent variable you want to predict. So these separate arrays are often required for machine learning algorithms that work with numerical data. So this code snippet separate the features, that means independent variables from the dependent variable in pandas data frame. So that's stored in this dataset variable. So according to our dataset, this country, age, salary, these are features, and this purchase column is the dependent variable. So now let's move to the code again. So this dataset dot ilog, uh, this part selects the row range, and second part selects the column range. So according to our example, this part selects all of these rows and all of these columns except this purchase column. So this means without dependent variable column, it selects all first three columns. So this dot values converts this selected portion into a data frame, portion of data frame into a numpy array. So from this part, our expectation is to selected the feature columns and save those feature columns in this x variable. So the result is then stored in this x variable, and now this array holds the values of all features in this dataset. Now let's run this section and see what is the output of x. Here you can see our features are now stored in this x variable. The next one is for dependent variable. So we have to select the dependent variable column from this dataset and store it in a variable. This dataset.ilog. So this part selects all rows from this dataset and select only the last column from this dataset. So these values similar to before, this converts the selected portion into a numpy array. So the result is then stored in the variable y, and this array now holds the values of the target variable, values of the dependent variable for each data point. So now let's print y and see the result. Okay, so these lines, these lines and this line display the content of x array and y array respectively, allowing you to visually inspect the separated features and the dependent variable. So remember, importing the dataset is just the first step. As we move forward, we'll dive into various data pre-processing techniques to clean, transform, and prepare your data for effective machine learning applications. Okay, now in these inputs, you can see there is a NaN here and here. So it indicates missing values in our dataset. So before using this data for machine learning, we have to take care of these missing data. In the next section, we will see how we can do that. All right, data, the fuel for machine learning models. So these data can sometimes be incomplete. So missing values, often these missing data represented by NaN here. So this missing data can arise due to various reasons like data collection errors or sensor malfunctions. But fear not, using proper data pre-processing techniques, we can fill those missing values. So you can imagine a recipe with missing ingredients. So just like you wouldn't attempt to bake a cake with incomplete ingredients, so machine learning models struggle to learn effectively from data riddled with missing values. So let's see how we can address missing data in Python. So first of all, we have to choose a proper imputation strategy to fill these missing values. So the first strategy is deletion. So this is the simplest approach and it removes rows or columns with missing values. However, it can lead to information loss, especially if the missing data percentage is high. So the second strategy is mean, median, or mode imputation. So this approach replaces the missing values with the average or the middle value, median, or the most frequent value, mode, of the respective feature. So this is quick and easy, but might not be suitable for skewed data or features with outliers. So the third strategy is interpolation. So this approach estimates the missing values based on the surrounding data points. So techniques like interpolation or nearest neighbor imputation so can be used for this. But they assume a linear relationship between data points, which might not always be hold true. So the last strategy is the model-based techniques. So this approach uses machine learning models to predict missing values based on the relationship between features. So this can be more accurate than previous simpler methods, but requires careful model selection and training. So how do we choose the right techniques? The optimal approach depends on several factors. So like the first factor is like amount of missing data. For small amounts, deletion might be acceptable, while for large amounts, imputation or model-based techniques might be preferable. And the second factor is data distribution. So techniques like mean, median, imputation might not work well for skewed data or features with outliers. The third fact is the nature of the data. So consider the underlying relationship between features when choosing imputation method. So remember, there is no one size fits all solution. So experiment with different techniques and evaluate their impact on your model's performance. So by effectively handling this missing data, so you will ensure your model have a complete picture and can draw more accurate conclusions from your data. So now let's see how we can replace our example data set missing values using mean imputation strategy. So first we have to import the simple imputer class from sklearn, the scikit-learn library. The next line creates an impute object specifying the imputation strategy mean that we are using in this example, and also it specifies to replace the missing values represented by nan in our dataset. Using this imputer.fit method, so we can train the imputer on the columns containing missing data. So in this example, we are applying the fit method to age and salary columns. So here you can see the age column and salary columns are numerical columns. So here you can see a missing value here and also a missing value here. So that means the fit method applies to column index 1 and column index 2. So therefore the column range is 1 to 3 here. So the column range is 1 to 3 here, definitely for all the rows. Finally, this imputer.transform method replaces the missing values in the specified columns with the imputed values, and it also assigns the output from this part uh, into this variable. That means in this x array it replaces the nan here and here with the mean of the respective column. Okay, now let's print and see what is the transform output. First we run this part, and this part. So here you can see two missing values, this one and this one, replaced with its column mean value. Remember, choose the right imputation strategy depends on your data and the nature of your missing values. So always explore different options and evaluate their impact on your model's performance. So next we jump into our next section, encoding categorical data. Machine learning models primarily deal with numerical data. But what about the features like city names, genders, or product categories? These are categorical data, so containing text labels, so that need to be transformed into a format understandable by models. This is where encoding comes in. So there are two common encoding techniques in Python. So the first one is one hot encoding, and the second one is label encoding. So this one hot encoding, so this method creates a new binary column for each unique category. So each data point gets a 1 in the column corresponding to its category and zeros in all other column. So let's see a small example and understand how one hot encoding works. So in this example, you can see there are three categories for city column: Paris, London, and New York. So in one hot encoding method, so it will create three new binary columns for each city. So for this city, there are three columns. So each data points get a one in the column corresponding to its category and zeros in all other columns. So in here for Paris, you can see the first column is 1 and all other columns 0. And for London, second column 1, other two columns 0. For New York, the last column 1 and other columns 0. So this is how one hot encoding technique works. The next we'll see how label encoding works. This method assigns a unique integer to each category. So in this example, you can see for each category in the city column, there is a unique integer. Remember, the choice of encoding technique depends on the nature of your data and the specific requirements of your machine learning model. So one hot encoding is generally preferred for models that treat categories as independent features. So that means those categories don't have any order. While label encoding might suitable for models that consider the order of categories. So now let's go to our example again. In this example, we will apply one hot encoding for the country column here. Since we don't need an order between the categories in our country column, so the one hot encoding is the suitable encoding method for that column. So first we have to import column transformer and one hot encoder from the S- scikit-learn compose and pre-processing modules. So next we create a column transfer object, and this object accepts a transformers parameter that is a list of tuples where each tuple defines a transformation to be applied. So in this example, we only have a one transformer. So here in this list, we only have a one tuple. So the first element of this tuple is the name of the transformer. So the name of the transformer is encoder here. And the second element is that the encoding method. So in this case, the one hot encoder. And the third one is the where should be applied the encoder. So the object should be applied to the first column. That means the column index 0 of the dataset X. This remainder parameter tells the column transfer what to do with columns, not explicitly mentioned in the transformers list. Here pass through means those columns will be passed through the transformer without any modification. So after that we can use this ct dot fit transform method uh, to transform the data. That means encoding the categorical feature in the first column using one hot encoding. So after that, we'll run these lines and see the result of X now. Here you can see three new columns are there instead of this single country column. And for each category, there is a single column represented by 1 and 0. So for Sweden, the second column is 1 and other two columns 0. So if we take UK, the third column is 1 and other two columns 0. And for Germany, first column 1 and other two columns 0. So by encoding categorical data, you bridge the communication gap between your data and the machine learning model. So enabling them to leverage this valuable information for effective learning and prediction. So after that, we can also encode the dependent variable. So our purchase state column in a data set. Okay, now we have tackled categorical features, but what about the dependent variable itself? So here you can see our dependent variable also text-based variable, I mean categorical variable. So in some cases, so this dependent variable might also be a categorical variable. So it containing labels like passed, failed, high, medium, low, something like that. So just like features, encoding the dependent variable ensures clarity and consistency for machine learning models. So here's how we can encode the dependent variable in Python. So for this, actually we can use label encoding method. So let's see how we can apply label encoding method to our dependent variable column. So here we import label encoder from this scikit-learn library pre-processing module. So next we create a label encoder object from this line. After that we can use le.fit underscore transform method to fit it into Y array to train encoder on the unique categories presented in the dependent variable Y. And also using the same method, it applies the encoding and replacing the text labels with the corresponding integer values in the Y array and assigning it to the Y variable. So now let's run this section and print and see how Y array looks like now. Here you can see our Y array also now converted into integers. Remember, encoding the dependent variable is not always necessary, especially for regression tasks where the target variable, the dependent variable, already holds numerical values. However, for classification problems, categorical dependent variables encoding ensures the model can effectively understand and predict the desired outcome. By encoding both features and the dependent variable, you will prepare your data for seamless integration with machine learning models, paving the way for accurate and interpretable prediction. So after we complete encoding, we can split our data set. In the next section, we will see how we can do that splitting part. In machine learning, splitting the dataset ensures your model doesn't simply memorize the training data, but it also applicable to unseen examples. So why is splitting important? So the first thing, it prevents overfitting. So if your model solely learns from the training data, so it might perform exceptionally well on that specific set, but fail miserably on new data. So splitting helps avoid this by creating a separate testing set for evaluation. And the second thing is, this splitting simulates a real world scenario. So in the real world, model encounter data that haven't seen before. So splitting mimics this by allowing the model to train on one part and showcase its applicability on unseen testing part. So how do we split the dataset in Python? So for that, we use the train test split function in scikit-learn library. So as usual, first we have to import train test split function from this scikit-learn model selection module. So this function takes four arguments. This x is the features array. This y is the dependent variable array. This test size indicates the proportion of data to be allocated for the testing set. So here it's 20%. That means, according to our example, 8 rows for training and 2 rows for testing. This random state. So this random state ensure reproducibility. So this is a pseudo random number parameter. So this allows you to reproduce the same train test split each time you run this code. So now let's run these code sections and see how our data set split into train and test sets. So here this function returns four variables. So the first one is xtrain. So this is training set for features, and the second one is x underscore test, and the testing set for features, and the third one is ytrain, training set for dependent variable, and the fourth one is ytest, dependent variable testing set. Now let's see each variable. Let's print each variable and see the output. Here you can see 8 rows for training set, x train set, and 2 rows for x test set. And here you can see eight outputs, eight data points for y train set, and two data point for y test set. Remember, the choice of the test size depends on the size of your dataset and the specific requirements of your model. The common ratio is 80% for training and 20% for testing. So by splitting the dataset, you ensure your model has dedicated training and testing grounds, fostering robust learning and applicability for real world application. Okay, now we have explored various data pre-processing techniques, but one crucial step remains. So that is feature scale. So imagine athletes competing on a racetrack. So wouldn't it be unfair if some ran on a shorter track while others had a longer distance? Similarly, in machine learning, features with different scales can be bias your models and hinder their performance. So think of features as ingredients in a recipe. So some ingredients might come in grams while others are measured in cups. So feature scaling ensures all your ingredients, I mean the features, are on the same measurement scale, creating a level playing field for your machine learning model. So, why is this feature scaling important? So, it improves the model convergence. So, certain machine learning algorithms struggle to run effectively when features have vastly different scales. So, this scaling helps them converge faster and achieve better results. The second importance is prevents bias towards dominant features. So Features with large scales can overshadow others in calculation, so leading to bias models. So scaling levels the playing field and give each feature an equal voice. Now let's see some common feature scaling methods. The first one is normalization, and under normalization we are talking about the min-max scaling method. So this method brings all feature values between 0 and 1. So here's the formula for min-max scaling method. In this formula, here x is the original value in the column, I mean the data point in the column. This x underscore min is the minimum value of the feature column, and this x max, x underscore max, is the maximum value of the feature. So using this formula, you can calculate the x underscore normalized value for each data point. So normalization is a good choice when you have features with widely different ranges and want to ensure all features are within a specific boundary like between 0 and 1. And also know the distribution of features is not strictly Gaussian, and you need a more robust scaling method to manage outliers. So for an example, let's say you have a data set with two features like age and income. So for age, the values range from 20 to 65, and for income feature, the values range from $20,000 to $200,000. So if you apply min-max scaling for this, so the normalized age feature would fall between 0 and 1. So the normalized income feature would also fall between 0 and 1. So what we have to do is you have to get each data point from this column and apply this formula to each data point in the column. So then as the final result, you can see all of the values in the column lies between 0 and 1. So this makes the ages and incomes are more comparable on a normalized scale. So this is how normalization works. The next feature scaling method is standardization. So standardization, also known as the Z-score normalization. So for this one, we are using this formula. So here x is the original value in the column, and this x mean is the mean of the feature of the column, and this x underscore std is the standard deviation of the feature column. So standardization is an excellent when you are using machine learning algorithms that benefit from normally distributed data, and you want to compare feature importance or contribution on a even scale, and when you are using distance based algorithms where relative scales of features matter. So for this, we can think example like this. Imagine a data set which features like weight and height. So the weight in kilograms and height in centimeters. So for weight, values range from 60 kg to 100 kg, and for height, values range from 150 centimeter to 190 centimeter. So after standardization, so after we apply this formula for each data point in this column, so the weight feature will have a mean of 0 and standard deviation of 1. Similarly, the height feature also will have a mean of 0 and standard deviation of 1. So this places both features on a common scale, so making it easier for machine learning algorithms to interpret and learn patterns. Now let's see how we can implement feature scaling in Python using standard scaler method. So this standard scalar method means the standardization. Uh, that means the mean and standard deviation based approach we talked previously. So first we have to import standard scalar from scikit-learn pre-processing module. So next we create a standard scalar object named sc. After that we can use sc.fit part to fit the scalar on the training data. So this actually calculates the mean and standard deviation for each feature from index 3 onwards. So that means we are applying this feature scaling to this age and salary columns. So that means this calculates the mean and standard deviation for each of this column and this column. So next we use this transform part in the same function to transform the training data using the calculate mean and standard deviation. So this subtract the mean from each feature value and divides by the standard deviation. So uh, according to our formula previously, so this each data point should subtract from the mean and divide it from the standard deviation. So resulting the standardized features with the mean of 0 and a standard deviation of 1. So after that, we apply the same transformation to the testing data using this line of code. So importantly, we only use transform here because uh, to avoid using information from testing set for scaling. So we are only transform this test data. We are not using the information from the testing set for scaling here. Now we can run these lines and see how feature scaling works. Okay. Now you can see for extrain set this age and salary columns now in a same scale, and for X test also this age and salary columns are now in a same scale. So remember, choosing the right scaling technique depends on your model and also based on your data. So standard scaler is a common choice, but other options like min-max scaler might be suitable in specific scenarios. So by applying feature scaling, you ensure all features contribute equally to the learning process, leading to more robust and applicable machine learning models. So, and that's a wrap up on feature scaling. So, by understanding its importance and implementing it effectively, you have equipped your data with the necessary foundation for successful machine learning journey. Remember, data processing is an essential step in machine learning journey. By taking the time to clean, transform, and prepare your data, so you pave the way for building robust and accurate models. So stay tuned for further exploration of exciting machine learning concepts. So in the next video, we will delve into the world of model selection and evaluation, helping you to choose the best model for specific tasks.